My name is Maryam from Northeastern University, and today I'm going to talk about privacy and security risks in the eSIM ecosystem. To start with, let's briefly understand what is an eSIM. eSIM technology is changing the way devices connect to cellular networks. Unlike traditional SIM cards that require physical distribution and manual activation, eSIMs are embedded directly into the device and allow remote provisioning of cellular profiles. This makes the setup seamless, fast, and incredibly convenient, which explains why eSIM adoption is growing so rapidly. We've already seen some major shifts in this domain, like iPhone 14 in the United States, which doesn't even have a SIM card anymore, and it's eSIM only. So the big question that comes to the mind is that does this convenience also invite new risks? In eSIM technology, some of the threats that we see aren't entirely new and they have existed before. The difference with eSIMs is that those threats are now easier to scale, harder to detect, and simpler to execute. Take SIM swapping, for example. It becomes easier since everything happens remotely over the air and it only needs a QR code or a link. Except from those kind of attacks, eSIMs introduces new actors into the ecosystem, like eSIM resellers or white label providers. In those cases, users often don't know who actually is controlling their profile, and the system, of course, lacks transparency. So, while eSIMs offer technical advancements, we can say that they also amplify old risks and create new ones. In this presentation, I will walk you through our analysis into four main areas. First, I will go over some routing and jurisdictional exposure analysis of travel eSIMs to understand how they route users' data. Next, I will talk about proactive communication and silent behavior of some of these travel eSIMs, where the user have no idea of this communication. Then I will dive into evaluating some eSIM resellers in order to investigate how much control and visibility they actually have and what this means for the users. Finally, I will discuss several challenges in eSIM profile management to see what can go wrong when the user don't have full control on their eSIM profiles. Nowadays, many users all around the world are buying travel eSIMs. Many brands now are competing in this space and they are offering diverse options with very attractive prices. The question that comes to the mind here is that what happens to your data when you're using travel eSIMs? For answering this question, we purchased more than 20 travel eSIMs from different providers and we installed them on our test devices. You can see here in this table a list of travel eSIMs that we tested. For example, one of the travel eSIMs that we tested was Holofly. Their headquarters is in Europe and we installed their eSIM while we were physically located in the United States. What we found was surprising. We noticed that all the users' traffic was routed through China Mobile Network. Even the IP address that was assigned to the phone was geolocated to China. And it's not just about China. Other eSIMs that we tested also routed data through different countries like Poland, Germany, or Singapore. And the user has no way of knowing this in advance. And mostly there is no transparency at the point of sale. To further understand this, we took a deeper look at what is exactly happening in the network layer. For the same example, Holofly eSIM that we had, you can see in this table the result of traceroute to google.com. It shows all the IPs that the data is being routed through. And as you can see, all the IPs are geolocated in China, and some of them belongs to China Mobile Network. What we found is that most travel eSIMs are utilizing roaming arrangement called home routed roaming or HRR. In HRR, the user data is not being routed locally through the country that they are physically in, but the data is tunneled all the way back to the eSIM provider's home infrastructure. This gives the provider full visibility into the user's web activity. and it can be problematic in terms of jurisdictional exposure. It is definitely privacy risks in travel eSIM market. Now let's talk about something that is even less visible to the users, the proactive communication. Proactive communication initiated by the eSIM profile itself. Proactive communication in general refers to the ability of the SIM or eSIM profile to initiate actions or even transmit data without any user interaction. To explore this, we used Sysmo EUICC1 and SIMtrace2 to observe the communication between the phone and the profile. We tested several travel eSIMs like eSIM Access, Holofly, and Numero, and we tested these profiles in different conditions like the phone startup or during the initial network registration or even also during some idle connectivity. For some of the eSIMs that we had, like Numero, we didn't observe anything unusual. But for eSIM Access and Holofly, as an example, we observed some proactive communication. Here you can see the Wireshark capturing, showing the proactive communication for eSIM Access. eSIM Access here opened the channel to an IP address in Singapore without any interaction from the user side. You install a travel eSIM and suddenly the phone is silently talking to a server in another continent with no app running, no user prompt, and it's just hidden network activity that is triggered by the SIM profile itself. We are not here saying that all proactive communication is malicious. Many of them, of course, are legitimate, but our point is that there is no visibility, no consent, and no standardization for users to review or even disable this functionality when they don't fully trust the providers. We talked about travel eSIMs. Now let's shift the topic to eSIM resellers. In the traditional model, your physical SIM card and the service that you were using came directly from a licensed mobile network operator, MNO or MVNO, and you knew who you were trusting. But eSIMs have enabled a new business model called eSIM reseller. An eSIM reseller is a third-party provider that sells mobile connectivity by provisioning eSIM profiles without having any infrastructure. Nowadays, literally anyone can become an eSIM reseller. The barrier to become an eSIM reseller is surprisingly low, and sometimes there is no identity check. With just a credit card and an email, we were able to gain access to some dashboards showing user profiles status and their usage history. This raises one important question, and the question is that what user details an eSIM reseller can have access to. To understand this, we joined several reseller platforms like eSIM Access, Mobimatter, or Telnex. All of them allow third parties to offer mobile connectivity by reselling eSIM profiles at wholesale prices. Here you can see some examples from Telnex specifically. Telnex provides approximate location information for any active eSIM profiles. Again, user location is always disclosed to the major network operators. The difference here in this scenario is that the location information is available to the eSIM resellers, which is not that much trusted. Telnex also provides the ability to assign public IP addresses to each eSIM profiles. That means you can make the user's phone accessible from the internet. A malicious reseller can assign public IPs to target devices and send them malicious traffic, and this would be a significant security risk. Now let's turn to profile management and the new challenges that eSIMs can introduce. Unlike physical SIM cards that you can simply pop in and out, eSIMs rely on some sort of digital provisioning protocol, which means deleting or even disabling a profile requires communication between the EUICC inside the device and the SMTP server. Here you can see two examples where things can get tricky. In the first example, which is about the profile itself, you can see that the profile can be designed such that it's non-deletable. This can be defined by something called profile policy rule, And according to the GSMA specifications, eSIM profiles must be deletable under normal conditions. But theoretically, it's something that can happen. Consider an attacker with the ability to design and distribute such a profile. Then the victim may have no way to remove the malicious profile. The second issue or the second example here is with the deletion process itself. We performed some tests to see what will happen when something interrupts the process. When a user deletes an eSIM profile, the device sends a delete notification to the SMTP server. Now, if this connection is somehow interrupted, the SMTP server will never receive the delete notification. And this interruption can be due to, for example, an attacker who's preventing this packet from going through, or even the user simply could be offline. As a result, the server considers the profile active. So when the user tries to reinstall the same profile later, they get an error. And this leads to some sort of denial of service condition where the user cannot have access to the same profile. To wrap up, let me summarize the key points. In this presentation, we talked about how eSIMs in different domains can make it easier for attackers to target the users remotely. And we also mentioned the gaps in this ecosystem. This QR code that you can see in this slide is also referring to Zenodo, where you can find all of our datasets and captured logs. We believe that by raising awareness among the users and having stronger security measures and also improving the regulations, the privacy and security of the eSIM ecosystem can be significantly enhanced. Thank you.